Let's take a look at the third example. For example 3, we're using the graph of f to determine the following. So we have domain and range again. So we look at domain. What is our graph doing from the left to the right? Is it going to infinity, or is anything limiting our graph? And in this case, nothing was limiting what x could equal. So we put negative infinity to positive infinity for the domain. The range is how far it goes up and down. So we see that this graph goes down to 0, but not any further than that, and it never will go any further below that. And then it goes up for infinity. So we put from 0 and it's equal to 0 to positive infinity. The x-intercepts we can just pick out are -3 and +3, so I wrote those as ordered pairs. And the y-intercept is just simply that point right there, which was 0, 4. Then intervals of increasing, decreasing, and constant. So if we go from left to right, we have an interval that is decreasing, then increasing, and then decreasing, and then increasing. So no intervals were constant. But let's go back and put the ones in that were increasing. So it's increasing from -3 to 0 and from +3 to infinity. Those are the two places on the graph that it's going uphill. So we put both of those. The intervals where it is decreasing were this first interval from negative infinity down to -3, and also from 0 to +3. So I put both of those for decreasing. Then we look at relative minimums. There were two of those. This point here at -3, 0, and this point here at 3, 0. And the relative maximum point is at 0, 4. Notice it's definitely not the highest point on the graph, but it is a relative maximum out of these points. And then letter I wanted us to find f of 1 equals 3. So where is x equal to 1? What is y equal to? So we come over to x equals 1, and we can see that y would equal 3. So on the graph where x was equal to 1, y was equal to 3. The values of x for letter J. Okay, so the values of x for which f of x is equal to 3. We need to go to where y equals 3 and then go across the graph, and it looks like there are 4 values where that would occur. There's x equals 1 and -1, and it looks like from the graph it'd be approximately -5.5 and also 5.5, because we don't know any more information. We're just going to estimate that it is somewhere between the 5 and the 6 and the -5 and the -6. And the last question was, is there symmetry, and is f even, odd, or neither? So we would say that this graph is definitely symmetric about the y-axis, and it would also be an even function. We could pick out some points and determine that when you plug in -x, that the y value would stay the same, such as -3 when we change it to +3. Notice how the y value is still equal to 0. So we can also check the value of like -1, 3, and there's also the point 1, 3. So there's several points we could pick out to determine that even when we switch x for -x, that the y value stayed the same. And also visually, it definitely looks symmetric about the y-axis, excusing my drawing skills. But that's it for example 3. Another video will have example 4.